Yeah, hi Abbas. Uh, Hello, are you able to hear me?
Yes, I can hear you.
Oh,
Am I
okay.
audible?
Now, you are audible now.
How are you? Okay.
Yeah, good to see you. So we'll start at 2 p.m. and
Sure.
one of our volunteers, Sanskruti Misra, she will lead the session.
Awesome. Awesome. Perfect. Should I share my screen or?
Yeah, you can share your screen
Okay.
once we start. Yeah, now you can try to share your screen. Yeah.
Okay.
Okay, over to you, Sanskruti.
Hello, everyone. So, it's my pleasure to welcome Dr. Abbas, who is currently the AI leader at PwC UK. So, before joining PwC, he served as a applied sciences leader for the government of UAE and held the role of cognitive and analytics leader at IBM. Dr. Abbas earned his PhD in machine learning from the Bournemouth University and completed a postdoctoral fellowship in explainability and generative AI at NYU UAE. With over 20 years of industry experience, he has worked extensively in both theoretical and applied aspects of AI, publishing peer-reviewed papers and holding a patent. His current interest lies in reinforcement learning, ethical AI, and AGI. Dr. Abbas is also a fellow of the British Computer Society and the Royal Statistical Society. We are really honored to have you with us today and look forward to your talk. Over to you, Dr. Abbas.
Great. Thank you very much. Can you see the slide open, local, smart, open, generative AI, context aware?
Yes, yes, doctor, we are able to see.
Okay. Perfect. Thank you very much. Hi, everyone. I'm Abbas. I'm leading GenAI in City Innovation Lab since last year. And I'm basically applied scientist there. And this talk is around the title is basically open source, localization, and smart. Smart means using smaller large language models, comparatively smaller large language models, but with more accuracy, accuracy which other large language models they are committing. So it's basically title is that's why open Gen AI for context aware, and context aware means localization, fine tuning, and these things, and also agentic. Agentic AI is something which I would say comes back early this year. So this is basically part of this conversation as well. So the agenda is very simple. Initially, I will talk about open source GenAI components, deployment, management, how we are doing most of the things at very high level. I will talk about it because a lot of things they are, I cannot discuss them publicly, but there are some things which I published in my paper and I can talk about those things. The second thing is localization through fine tuning. Means in Odisha language, in Arabic language, any language you how easily you can fine tune these models. And also apart from language or prompt tuning, how you can easily fine tune your models, because whenever we are talking about open source models and smaller models, for example, 90 billion, 70 billion parameter models, then fine tuning is something which we can do very easily and very quickly. So how we can do this thing, and then I will talk about agentic AI. So let's begin with this open generative AI thing. In my current company, City Innovation Lab, and the previous one, which was PwC, and even the previous one, government of UAE, G42, you might have heard that name from recent Trump's visit, and all the investment of 1.4 trillion. Everything is, the platform is Group 42. So in these three organizations, my focus was on in-house generative AI platform. So, and I will talk about the same thing. In all of these three organizations, very big organizations, there are two paths going on. One is closed source GenAI, the other one is open source GenAI. Closed source GenAI means OpenAI, Gemini, or these kind of models which are which you can access it through cloud. And the open source is you can just get the models, their weights, or anything around the model, their architecture. You can download it from the web, and you can do anything with them. You can fine tune them. You can deploy them on your within your firewall, and these things. But what are some concerns, problems, and other areas or challenges involved or associated with this one, if you go for this route, for this open GenAI route? So democratization of GenAI using open source models. Basically, there are two concepts: model to data and data to model. So the cloud environment is basically is a data to model. Model is in cloud. So that's the model. But what we are talking about is bringing model to your enterprise data. So what are the different challenges and other areas which we can consider here? So in proprietary models, they are always expensive. Gemini 2.5 is more than 1 trillion parameter model. They are more of a general purpose models, consumer applications and all these things. Open source models are always free to use, fine-tunable, customizable, enterprise level application. Enterprises, they want to use open generative AI, except there is one big drawback of support, because enterprises, they can pay anything for the support. But that is missing there. Customizable, small and large, every type of models, you can get it from there. But if we talk about Gemini or OpenAI, there are only large models available, very large models available. For example, the smallest one is 100 billion plus parameter model. And architecture-wise, they are secured by design. We cannot say that our data is going somewhere. Our data will be used to adapt the model. For example, when OpenAI released their ChatGPT, someone from Samsung, they uploaded their source code and everything, and asked a large language model to test this code. That code became the part of the training data, and that code was available to the public somehow, or that code was being used to train the public models. So secured by design, behind your firewall, fully customizable, scalable, confidential. We can run very, very confidential data. There are 7 data classification in investment banking, and the type of data financial services institutes they have, and multiple use cases you can run. So from our analysis, the open source models, which were 70 to 90 billion parameter models, they were basically 5% we find that at that time, almost 1.5 years or 2 years ago, these were even 5% more accurate than GPT-3 models, which was 175 billion parameter model after fine tuning. And these models are 10 times smaller than the other models. For example, again, ChatGPT. And these models consume 20 times less power than ChatGPT and these kind of models if they deploy properly and serve at scale at enterprise level. So if we are going for generative AI route, what are the different things that we need to consider? So first thing is scalability. We need to make sure that, we need to make sure that when we are talking about the closed source models, OpenAI, Gemini, these models, we can just, these models are readily available. We can just use the API key and everything and start using it. But here, we need to come up with a very sophisticated inference and scaling thing. One of the most difficult thing in open source large language model is inference and scaling. It's not fine tuning, it's not evaluation, it's not anything, but inference and scaling is one of the most challenging tasks. How a lot of people, they can use your models, how you are parallelizing the request, batch processing, and mini batching, decoding, and speculative decoding, other things, how you are applying these optimization, quantization on the model in order to balance both accuracy and usage or availability of that model to maximum number of users. The second thing is security. These models, they provide you secure environment, which we already talk about. These are closed-ended model, and we can fine tune those models. So in that way, we could somehow minimize the hallucination of these models. So these are cross-domain use cases. I mean, you can run it, you can fine tune it with every use case. And definitely these are low carbon. These models, or this route has low carbon footprint. So, I mean, when we deploy this model, we are currently, and for like last 2 years, I would say, we are doing multiple things. We are running it for text-to-text thing. For example, text input, text output. We are doing it for content generation. We are doing it for tabular data analysis. For example, text to table or table to text interpretation or generating a tables, and then image generation. Image to text to image and image to text, and then speech to text. So we have 4 or 5 modalities: text, table, structured data, unstructured data text, structured data tables, images, and video. So, and speech. These are 4 or 5 things that we have. So around all these things, we have different models. Earlier we were using different models, but now we are using same models because these are multi-models these days. So the RAG that we have implemented is very simple RAG, where we are basically using the model, a large language model. Then we have re-rankers there, which are basically on vector embeddings. We are using a, so in RAG, we have 2 things. One is basically the retriever. The other thing is generator. So in retriever, we have, again, open source models, for example, BGE, NVIDIA's NV something, NV embed, I believe, or other good models are there, which at semantic level, giving us shortlisting the relevant passages to a prompt. And then once we shortlist the passages, against a prompt, then we are sending it to the models, and our context windows are very big. It's around 32K tokens. Input prompt and output prompt is also from 16 to 32K tokens. So that's basically our, input and output things. So every stage, and then we are using this FICE vector database, PG vector, and other open source vector databases we use. So in each and every components, in each and every level, we are using open source components in order to get hold of everything. So that's one key component and very obvious component. The second component is a very useful component. We are getting a lot of files, PDF files and other files. We are not getting, we are unable to properly extract the data. So there is a generative AI, there was shallow learning. So traditionally in machine learning, it was task specific. We could either perform tabular data analysis or we could do text analysis, unstructured data analysis, or we could do some other analysis, one task at a time. So we were preparing the data, we were curating the data, we were doing some kind of engineering and all sorts of things. We were applying it on one problem. However, in generative AI, our behavior is changed. So what we are thinking that LLM has to come up with some kind of magic, which is not true. So what we are doing, because LLMs are multi-model, we are blindly ingesting the complex PDF documents in LLM. LLM is unable to read more than 60% very useful data from the PDFs. So that's why, that is one of the reason our models, they are failing. What we are doing there, so we have spent a lot of time on only data extraction, accurately extracting multi-model data from PDFs. So we get the PDF, we convert it into pages. Pages means images, and then we basically apply some kind of segmentation. In a PDF document, what are the different modalities that you can get? Text, images, tables. These are the three key modalities. So we have a computer vision based segmentation model. We are using it, which we fine tune it. It's like YOLO X style model, which we have fine tuned it. And that model basically put a bounding boxes that this is text, this is image, this is table, this is image 2, this is table 2, text 2. So in this way, it is basically giving us the bounding boxes or the coordinates of the text area, table area, image area. That is step number one. All the text we are sending it after applying some kind of minor pre-processing directly to our repository or for the vectorization. The images, we are doing two things with the images. If multi-models are available, we are extracting embeddings of the images. The second thing we are doing is we are interpreting those images using image-to-text models. So there is a graph, a pie chart. So we are sending it to the image model and asking image model to interpret that one in, and don't leave any specific information, and these kind of things we are mentioning it. So on the other side, what we are getting is, this is a pie chart. It has five, different categories. The significant category is this one. The minimal category, most insignificant category is this one. The remaining categories are this one. These are the percentages. These are the things. In 2 to 3 paragraphs, we are getting very good interpretation, which can be, which we can digitize, which is digitized, and which we can use it through prompt. Okay, so this is basically images with the tables. Tables in financial services are the most complex things. So we are further applying some techniques on the table. What are those techniques? Basically, we are further applying some computer vision based models on only images, because this previous model gave us the image table image. So on top of it, we are trying to identify the rows and columns, because in financial services the tables are very complex. In one column you are getting multi-line, in very next column of the same row you are getting single line, and then so on. If you are not applying some kind of bounding boxes or not using sophisticated models, in that case your entire table will be giving you completely wrong information 100% times almost, or 99% times on the safe side. If you have two lines on this one line on the next two columns, what it will do, it will just push the second line in the next column, and then the column headers will not be mapped from the from the rest of the table. I mean, the alignment, it will be misaligned. The column names versus the values. This is what we have observed. And there are a lot of combinations. There are tables without borders. You are not getting any lines. There are very narrow tables. You can just imagine the research papers. In a lot of templates, we have very minimal markings, or we have, no table borders are there. In other cases, we have a lot of table borders where information is somehow, overlap with the border of the tables. So in that way, we extract the information from the table, convert it into a JSON or any digital, any format which is recognizable to LLMs, and then we start putting it into this one, and then we apply. This is a digitized text repository, and then we apply, we extract embeddings and provide it to this. Then we are using a lot of other things. We are using keyword-based thing. We are using semantic similarity-based, this vector database, or we are extracting the embeddings from the semantic models. We are using graph to understand these things, knowledge graphs, and then we have some other approaches that we are currently experimenting. So this was about the application level. So now how the inference thing is done. This is not the exact diagram, but this is giving at least very high level view of this one. If you would like to read more about it, I have a research paper which I can share it, is discussing all of these things. 2 years ago, we published it, NVIDIA, PwC, and Capgemini. So in this one, we have different layers. One layer is application layer, one layer is user layer, the other layer is backend layer, the third layer is LLM layer. So we basically communicate over HTTPS secured protocol, and then we are sending this text prompts to the LLM backend using API service, using gRPC. RPC protocol, and then we have again the same Kubernetes and other structure through which we can scale it and other things. And then within the model, we are applying input queues, mini batching, schedulers, quantizations, and other things in order to optimize these things. And we are using different things: VLLM, NIM, TensorRT, and different models are there. And then we have different compute H100s, A100s, H200, and now we are going for B200 and B300 Blackwell. So this is a very high-level architecture. REST is our IP. I mean, and there are a couple of other optimizations that we are using, but this is the overview here. I mean, it's a glimpse of what exactly we are doing it with different things. The next thing is observability. So your large language model is black box. So if you are blindly using that one, I mean, at some point, at enterprise level especially, you will be getting you can get any kind of problem you can face, and you will be blind about this one. And most of the time, we don't know that this issue is coming up until unless we get some loss in the accuracy in any other way someone is escalating it. So what we can do is there are two things: observability, explainability, evaluation, and explainability. There are three things. Observability is the bigger circle. Within observability, evaluation, and explainability, these are the two things that we are using. So I will talk about evaluation and explainability. So in evaluation, we have two paths further. One path is, okay, you are sending a prompt to ChatGPT. Let's say you are using ChatGPT every day, a lot of times, maybe at least during the weekdays. So when you are sending your prompt, you need to verify it. So do you have any ground truth available? You are asking a question to ChatGPT. Do you have any ground truth available? It's a generative AI. Generative AI means it is gonna generate the new data, which does not exist there. So if it does not exist, from where we will bring the ground truth? That means there is no ground truth available. So in generative AI, the biggest problem is there is no ground truth. You can generate any data, but there is no ground truth available. That this is the golden answer of this question. You can change the prompt. You can write any prompt. You can send any prompt to the large language model. How you will come up with the ground truth? So we have two paths. One is where we don't have any ground truth, and the other one is ground truth available. For example, we have very small use case, very limited use case, and we have prepared the ground truth, a golden data set, that if user is asking question anything around this one, its answer should be this one. This question answer should be this one. And then we can match it. In case of ground truth is available, or fine-tuning is another example. When we are fine-tune our model, ground truth is also, ground truth or golden answer is always there. So in that case, we use this model. We use Blue Score, ROG, Accuracy, Comet, Blue RT, or these kind of approaches, or LLM as similarity. For example, this is original question, this is original answer, or ground truth, this is generated answer. So how similar both of these are, because LLMs usually generate very long answers, and sometimes Blue Score and other scores, they does not work. So we use a lot of different matrices and we combine them. Where we don't have ground truth, which is the actual case, we use two approaches further: LLM as a judge for some of the approaches, and encoder-based models, smaller models, encoder-based models we train to, bird-style models, you can say, we train to find these things. So what we do, we got a response and we don't have any ground truth, but we have some kind of context there. We provided context to the large language model, question to the large language automatically, and then we have generated response. Three things: context, question, and answer. So Now we want to give it to large language model to find it out how good it is, and whether it is hallucinated, whether it is diverted, whether it is biased, whether it is unfaithful, means not giving us the right answer, whether it is disclosing any of our personal or confidential data, or whether it is using abusive language. So all of these things we can control from these matrices using either encoder-based model. Wherever we can use, we should choose this encoder-based model. Some of the things, for example, clarity. Clarity we can check from LLM, and relevance is not LLM thing. I'm sorry for that, but trustworthiness and faithfulness, these kind of things we can test it from LLMs, and then robustness and fluency and perplexity. We can for perplexity we have different models. I'm sorry for that. We have different models available, encoder-based models and other things. So that is basically evaluation. So here you can see there are 10 to 12 areas: RAG, data extraction, fine-tuning, data curation, explainability, evaluation, observability, and so on. There are, almost 10 to 12 areas which are the different phases of Gen AI lifecycle, which we are covering in that one. So explainability. Explainability is something just like in case of computer vision networks, we use the last fixed feature vector layer in order to get the explainability why we got that answer. Exactly the similar kind of thing we have tested it on smaller models, for example 8 billion parameter models, and now we are going to use 70 billion parameter models, that against one activation function, what are the different activations which are activated in the network, and we could somehow get some relevance and some true explainability. People, they are confusing COT, chain of thought, with explainability. Chain of thought is not explainability. The true explainability is a bit difficult in this one, in generative AI. We were earlier using knowledge graphs for explainability purpose. So this is privacy thing in the bank. Privacy is the key thing here. So what we are doing here is we are sending a prompt to our anonymizer. Anonymizer is basically replacing all the entities into fake entities. And then it is creating a dictionary that Paul Adam was replaced with James Smith. This birthday was replaced with this one. And then this fake thing, you can send it either outside city network, not very public network, but enterprise, or you can use it within our in-house generative AI platform. So, and then you can get the response. So based on our experimentation, these entities are not changing the response a lot. We are getting almost the same response regardless regardless we are sending James Smith or Paul Adam. As far as in all the instances we use the same name. If Paul Adams is being used in 5 instances, we need to replace the same name, same fake name in those things. So when we are getting the response back, we are from the dictionary we prepared for original versus fake entities. We are using that dictionary to put the original thing back before sending it to the user, de-anonymization. Then we don't have a lot of time. Then we have a lot of other microservices. We have fine-tuned our models for downstream tasks. For example, machine translation. We have different translation thing. Text classification is very key thing. We were using previously shallow machine learning models or traditional machine learning models for that. Then machine reading comprehension. What is RAG? RAG is machine reading comprehension. So we have fine-tuned a model for that one as well. Topic modeling, entity extraction for knowledge graphs, relationship extraction, tuple extraction, object subject, and relationship. And then for OCR, we have a lot of images. For example, invoices, we are getting 500,000 invoices per quarter. So how we are digitize those invoices using image to text, and image generation for different purposes, network diagram understanding, their digitization and workflows, and then different applications. So these are the microservices that there are a lot of other things, but unfortunately I only have 1 hour, so I cannot talk about these things. The next topic is localization. What we are doing, we have basically in PwC, I was supporting Middle East region as well, and Arabic language was the key there. So we use different data set. For example, Dolly 16B, 16K instruction set, and 52K instruction set. These kind of instruction set, we translated it using Google Translator, and then there were KSU and different universities. They basically parse it, that the instruction tuning data set from English to Arabic that we have translated using the statistical machine translators, whether they are translated properly or not. Once they verify that data, then we tune those models. 1.5 or 2 years ago, when Arabic models were not common, so we tune those models, and we can do it very easily. It takes 2.5 months and very less effort. You can pick a instruction tuning data set, open source instruction tuning data set. You can translate it using any SMT, a statistical machine translator, and then you need to linear parse that data, whether there is any mistake, or language localization is very important, which local people can only do, which can be done by local people. So that is another thing. Other than that, because we are using smaller models, 70 billion parameter model, 90 billion. So fine tuning is the key. But we have a lot of use cases. We have 1,500 plus use cases at one time. So how we can curate the data for most of the use cases where we are not getting good accuracy, after applying all of the optimizations that I'm talking about for last 30 minutes. So we have a curation tool which we have prepared. So in that curation tool, we basically gather all the training data. We extract, using large language model, we extract number of questions. We convert entire text, entire repository into passages, long passages of 4096. And then we ask large language model to generate 10 to 15 very useful questions, inferential and useful questions, rather than these kind, what is this paragraph about, what is these things, what is this, not these kind of questions, very useful questions extract from the passages. And once we get the list of questions, for example, around 3 documents, we have 150 questions. Then we use RAG kind of mechanism to verify, to get answer of those questions. We have knowledge source, knowledge base, we have set of questions. We can apply RAG to get the answers. Once we get the answer, then we basically we have a tool, collaborative SME evaluation tool. There are more than 2 SMEs. They basically evaluate the responses one by one. And if more than 2 SMEs, more than 50% votes are saying that the answer is right, or there are minor changes we need to do to make this question and answer pair right, then we can include it in training set. Otherwise, we can exclude it in the training. And we also use our automatic evaluation criteria to help the SMEs that whether there is any hallucination, there are other things. So in that way, we could somehow expedite the process, minimize the time, and quickly we prepare the data, and then we use LoRa PEFT or thorough fine-tuning or some other optimized fine-tuning ways. For example, using dimensionality reduction, we are somehow checking that which are the activation functions which need to be optimized in case of thorough fine-tuning. And then we are deploying these models. This is the process I was talking about, the documents, its tokenization, chunking of the text, question generation, answer generation, and all of these things. And that's how this is the agentic approach. That's how we are deploying large language models. We have one large language model and we have 5 adapters, fine-tuned adapters. Either we are going to deploy 5 70 billion parameter model and associate each fine-tuned adapter with that model. No. We'll only deploy one base model, one 70 billion parameter model, and there'll be different adapters based on the nature of the query which controller LLM or orchestrator of the simple agentic flow will do, and send the query that whether it's a HR related query, it's a finance related query, or it's a policy related query. So these adapters are already there in the memory. At runtime, they connected with this one. I'm not saying that this is not in production environment yet, but in our UAT we are testing it and it is working fine on H200, H100 basically. So now my last topic, I have already consumed a lot of time. My last topic is around Agentic AI, what we are doing in Agentic AI, how we are defining Agentic AI, and all of this thing. So the very first thing is we define Agentic AI. Why? Our 240,000 employees, a lot of employees, they were confused. Most of the time, they were confusing Agentic AI with agents or with simple workflows. So what are these two things? Agentic AI and AI agents. Agentic AI is something which is fully or semi-autonomous, which is goal-driven, solve problems on its own. We just give a complex problem and it automatically break down that problem and solve it, rather than we are splitting a complex problem into different tasks. Handle complex and dynamic environment, makes decision based on reasoning and analysis rather than making decision based on human intervention or human thinking. Changes its goal and methods autonomously. AI agents or simple workflows, they are very limited. They have very limited autonomy. They are solving small tasks, not very complex tasks. They cannot solve very complex tasks because these are simple flows like this one. These are simple flows. If it's HR related query, trigger this agent. If this is, trigger this one, and there is a controller LLM. There is an LLM which is transcribing it, which is recognizing it. These 3 are the option where I have to send just a router. But Agentic AI is much more than this one. It's task specific, follows instructions from human, handles simpler or more structured tasks, not very complex tasks, pre-programmed response to input, and all of these. I will only talk about Agentic AI. So what are the Agentic AI? What is Agentic AI? Most of the things you can read from the slide. But there are few components of Agentic AI. Reflection, self-reflection. In case of any problem, it is self-reflecting it and automatically resolving the problem, or at least trying to diagnose the problem. Set of different tools. For example, what are the other large language models, other small language SLMs, other encoder-based models, or even a function, a very useful function, Python function, C function, is being used here to solve this task. These are the tools. Usage of the tools. Planning and reasoning. That capability is very important. If you are unable to plan and reason, you cannot automate your task. And then multi-agentic capability, which is another thing. So what is AI workflow? You send a prompt. There is an AI model which works as orchestrator or router, and then it send the task to the right path and then gets the response back. Agentic workflow is something where you send a prompt, it basically make a plan. How I explain Agentic AI, you guys are more learned than me. I'm just discussing it with you. I cannot educate you or give you any knowledge, but these are the obvious things. Agentic AI, I explain it to people, is something like the computer science concept, which is divide and conquer. You split a complex problem into simple tasks and then send it to the model to solve it. So I will give an example, and then I'll conclude my talk, and then we'll go for the Q&A. And then execute those actions. Once you split a problem into simpler tasks, what is the computer science mechanism of solving complex problem? Divide a complex problem into simpler and related tasks, and then solve each and every task, and then combine it. Divide and conquer. This is the approach behind Agentic AI. Making a plan means dividing a problem into related and simpler and related tasks. Related is the key word here. Execute actions. Whatever tools needs to be used to solve that task, use those tools, one or more than one, and get the answer, verify the answer, evaluate the answer, go for the explainability, reasoning and everything, and verify. If you got the verified answer, that's fine. If not, then terminate the process. What are those components? Self-reflection, tools usage, memory, different types of memory, agent level memory, shared memory across the agents, and other memory, planning and reasoning, SPIs, multi-agent capability, ease of use, complexity versus customization, because when you are going for complex use cases and other things. So evaluation and explainability, protocols, and there are other components as well. Now, I have only 3 slides left, and it will take 5 minutes. This is a very simple picture for large language model. There are very sophisticated large language models, and this is a very simple picture. It is not a very simple picture if we consider this prompt. How many batsmen are there on the field in the given image? All of the players, they are wearing white test cricket kit. So it is really hard. I mean, this is a wicket keeper, batsman. Overlapping is possible. Other things are possible. How we can just send this image and this prompt to the typical image to text models, and you won't get the right answer. So how you can do it? First, you can apply semantic segmentation. You can identify the bats, the object bat. How many people are there? For example, the batsman is unable to run, take runs, and he has a support. There is a third batsman there on the field who is only the runner. So in that case, it will be difficult. So first, identify the people who is holding the bat. And there you can use a tool, semantic segmentation. Then you can use instance segmentation, semantic segmentation to minimize the field. Instance segmentation, people holding the bat. For example, this is very high level thing. Don't go into the details. The idea is to tell you how a complex problem can be interpreted into simpler and related tasks, which can help us to solve the bigger or key problem, and so on. There could be other tools. Once you identify these things, you can count that there are two batsmen. So we are using agentic approach in the RAG, which is pretty much obvious, using external sources, using multiple approaches of retrieval, and for these kind of purposes, agentic RAG is good. And this is the last use case where I want to use, and then I will not waste any more of your time. Data analytics, using descriptive, predictive, and prescriptive analytics using agentic AI. So let's talk about predictive analytics, because descriptive analytics is text to SQL mostly. Predictive analytics. In predictive analytics, we need two things. We need data, we need algorithms, right? So I'm asking a question. A business user is asking a question: how my revenue would look like in next 3 months? So this controller LLM will translate this query into different related tasks. I told you about related is the keyword. So the first it is basically this exact query is converted into 3 sub-queries. First query was extract last 3 months data which we can use to train the model. And second one was they are talking about forecasting or extrapolation model. Generate a code using code LLM for a simple forecasting algorithm using the schema which we have extracted from text to SQL. We need to provide the schema, otherwise we cannot get the working code. And the third agent is basically pick the data from first agent, get the running algorithm generated by the second one, and execute it and return the results. What results we are actually getting? July 2025, this was the forecast. August 2025, this was the forecast. September 2025, this was the forecast. This was the exact results we were getting from this one. We tried it on very large, very sophisticated models, GPT-4 or GPT-4 reasoning or O or other models. We are not getting good answer because generative AI in one shot cannot maximize the goal. It cannot give you global maxima. This is my quote. Generative AI in one shot cannot give you global maxima. It will always hallucinate. Massively large data set, it will always hallucinate. In generative AI, there is no backspace. In generative AI, it generates the word one by one. There is no backspace there. You cannot revert anything. But agentic AI is the wrapper on top of generative AI, which can give you a facility to go back, review your results, and regenerate them, revise your results. So in that one, you can see if I'm generating this text using text to SQL, I'm extracting the data from database. Maybe I'm getting error. This self-reflection reasoning can send that error back to the LLM and say that I gave you this query, you gave me this error of 405 or this error. Please reconsider it. This is error. This is my prompt. Please reconsider it and give me the query which is executable on this specific schema which I have provided in the prompt. Similarly, on this code, we are providing some sample records and we are providing schema. So we can run and test that one. And then the last one in this one. So self-reflection reasoning is at every stage, it is there. There are different tools we are using and different things. So this is a complete example of this one, which we have implemented. We are using artifact. There are different types of memory. One memory is where it is holding the data set. The other memory is where this code and where this agent 3 is accessing the code and data from other agents' memory or on the shared memory or in the form of artifacts. This is a fine-tuning use case which I have already discussed with you. So this was my talk. Any question, please? I'm sorry, I utilized a lot of time. So please feel free to discuss anything, ask anything. If any concept is not right, please feel free to correct me on that one.
Hello.
Yeah.
Hello, Dr. Abbas. Am I audible?
Yep.
Thanks for the great session. It's very much explanatory. I have a couple of questions. Like you have mentioned about embeddings with columns and numbers. Let's take a scenario. Suppose there is columns with multiple lines, around 1,000 lines with numbers and corresponding pie chart and text as well. So how the embedding will be able to relate to multiple similar kind of things? It is a very complex thing. For example, 10.5 of a one column, 10.6 of same column will be having same embeddings, but another column will be having same number. So how it is happening?
Let me understand your question. So which topic you are talking about?
Data extraction.
Okay, in data extraction. In data extraction, you are talking about the tables part, right?
Tables, and for example, tables, images, multiple things are there for same topic. So how it is correlating multiple things?
No, actually, sorry, what's your name?
Tanmay.
Tanmay, it's basically very simple. There is image number 1, image number 2, image number 3, and image number 4.
Okay.
So we have a structure we define. First, text 1, then text 2, then image 1, table 1, text 3, text 4. We are assigning every bounding boxes, we are assigning an ID, sequential ID.
Okay.
And then we are sending them to their respective models for interpretation.
Okay.
After bounding boxes. And then on that front, this is very high level process flow diagram. This is not the exact. At that front, we are basically gathering it. This was the text 1. This is its clean text, pre-processed text. This is image 1. This is the description or interpretation of the image. This is table 1. This is the description or HTML of table 1. That's how we are putting it back in the same structure. And then we are applying extracted embeddings just like it's a text.
Okay. And it is automatically correlating with all this information when we are extracting during the retrieval.
Need to do it. We are getting some metadata along with the different modalities. We are getting the metadata that it is text 1. Its bounding boxes was 0.555 to this. A lot of metadata we were getting, and we are at this stage we are processing that metadata and putting them into their right structure.
Okay. And couple of other questions. Sorry.
Please.
We are mentioning about open source models. These are mostly done by communities who are not much funded. So how are you checking the RAI guidelines, how the data is trained?
Okay, great. Okay, so I just have one question, and I believe you will answer my question. Llama is open source, right?
Yes.
ChatGPT is closed source.
Yes.
Which model is more reliable? You have evidences of OpenAI using a lot of data which is not appropriate, which is not, which is not openly available data, which they have used. A lot of things they have used, they have accepted it, but Llama is not accepting anything. So, all the models, Gemini, Google is pretending that I'm very ethical. Yes. But Google is using most of this data because Google's approach is silence. Silently Google is doing. Sam's approach is, OpenAI approach is, they talk a lot. And that's why they are revealing their Meta's approach is they are intermediary. Their CEO wanted to, but their other community is silent. So that's the only things. All the models, without that one, we want to learn as much knowledge as possible. These are the world's largest models. They need world's largest source as much as possible. So we are just closing our eyes. We know the things. We don't have solution. We have to use this one. So ethically, next question, please.
Sorry. So PI data is getting synthesized to synthetic data. We are creating PI data synthesized. Suppose there is one person's PI data converted to another person, but the same person already exists in the company. So how these things are getting verified?
You are talking about PII, right?
Correct, PI.
This is very simple. We don't know the persons. We don't know the things. There is a prompt coming up. So, and we have a mapping of this one, Paul Adams. Okay, maybe there are two Paul Adams,
Yes.
right? For generative AI, even it's ambiguity, right? So it has nothing to do with privacy or PII. It has something to do with, we need to modify it. We need to give it that Paul Adam the good guy, Paul Adam the bad guy. In every enterprises you tag it, he's not a good guy, or any other kind of tagging. You need to mention it. For LLMs, whether you are applying PII or you are applying anonymization or not, it will be ambiguous for the large language model.
Yes. Okay. One more question. Sorry. MCP is on the way. Most of the companies are creating the MCPs. If we are creating tools for agentic applications which are doing similar work for the another company which is releasing the MCP, so is there an option of doing a hybrid kind of thing? Like if there is a MCP
across different companies?
Yes, suppose Salesforce is releasing their MCP, but a couple of weeks back, people are creating their tools to create the API call and do the things. So is there any fallback option? Sometimes you are using the MCP, but if it is not working, it is going to fall back your tool during the agentic development?
It is. We are, currently in love with Google these days. So, we are mostly using A2A, and also MCP is there, which we have, I would say, a customized implementation within the city. And I cannot talk about it a lot, but the thing is, it is very, very in closed loops within our network, and it's our own implementation.
Okay.
So that's what I can say. That I mean, we cannot because data is passing through these protocols. So these are the most confidential ones. So I believe other points, they are not relevant in that case.
Okay. Thank you so much. Thank you, Dr. Abbas.
Yeah. Questions, please. I would love to answer questions all the day, but unfortunately, I mean, we don't have enough time. But
hello, sir. Can you hear me? Yeah. So in a multi-agentic architecture, which you are showing, one agent was basically interpreting the natural language query from the user, and another agent is generating either a SQL or a Python code. So in your system, do you, particularly when you're dealing with sensitive data, is there any human in the loop to check the accuracy or quality of the code generated, or it is completely autonomous? Because that is, do you have any systemic check in place? What would you recommend?
Absolutely. So the thing is, it depends on the industry. Sorry, what's your name?
Abbas Smith.
It depends on the industry. In our ones, we first came up with the definition of agentic AI. If you see our definition of agentic AI, it's semi-autonomous. Autonomous or semi-autonomous. I was in the organization in the favor of fully autonomous, but we couldn't. Our risk team, they said, no. Let's park agentic AI. We don't need agentic AI. So semi-autonomous is something which you need to put it there. Actually, you know what we are doing? We are introducing human intervention in some places. For example, let me tell you. Did you use Devin for code generation?
Yeah. Yes.
Okay. So in our organization, we are using Devin for code generation and firing a lot of software engineers. We are using Devin. So Devin is basically what it is doing. We are sending a prompt. Devin is making a plan that this is this thing, this thing, this thing. And it is showing that plan to the user. And then user is able to modify that plan and execute it. So that's how we are involving human in the loop. So in every use case, there is a different route, different way to include the human in the loop.
Thank you very much, sir.
Yeah. Any other question, please? Feel free to ask anything, discuss anything around these topic, around this one. But Shanti will not allow you.
Hi, Abbas. Sorry.
I think a lot of questions for you.
Hi, Abbas. This is Soumya here.
Yeah.
Just a quick reference to your organization, PwC. Can you please help me reference this work which you showed, like data analytics and very deep understanding of generative AI, agentic AI. So how can we relate this kind of work to PwC's normal working projects? Because I come from India, so I know PwC working in a lot of government-related projects, mostly government-funded projects. And it's a consulting company, so you have a very structured end-to-end assignment with a deliverable. So can you please help me how much objective you are in delivering the projects and also using this high level of artificial intelligence knowledge? It's a very top level question to you, but please help me understand.
You guys are asking very difficult questions, I'm telling you. Okay. So
it's a very different question, I can understand. Yeah. But you come from PwC UK, so I expect that kind of professionalism in terms of, deep driving towards the deliverable and objectiveness of the projects which you're handling, and at the same time correlating with the knowledge which you're exploring.
Yeah. Okay. So PwC. I have worked a lot in PwC with PwC India, and PwC India is doing a lot of work. All the departments which PwC has, deals, consulting, and others, they are there in India. A lot of countries they are out in the world where they have very restricted areas. But in India, they have everything. India is doing everything. Trust me. I know more than you. At least the PwC, IBM, Citi, and all of these companies, because I have worked with India through these interfaces. So there is India, and there is other. There is Europe, and you can compare India with continents.
Yeah.
So they are doing everything. Now, coming back to your other point around these things, PwC India was doing it. How PwC was consuming it? PwC has, for example, one of the case I would like to discuss from PwC UK. PwC UK has a legal team of 4,000 lawyers. Those lawyers, they were getting a lot of data from their clients, customers, and they were taking, on average, 6 to 8 weeks of time to come up with the conclusions, PDF diagrams, evidences, and other things. When we gave them this tool, they uploaded all of their documents, and we gave them 22 to 25 prompts. And those prompts were summarize the data. Those prompts were find contradictions from the document. It was giving them something like, in document 3 of page 110, it is saying this statement. On document 5 of page this 117, it was saying opposite to this one. So that's how it was helping them. We reduced the time from 8 weeks to less than 3 weeks. You can imagine them how. Go on.
That's very excellent.
You can imagine them
time.
How we reduced that time from how much money is involved there. Those are very expensive UK-based resources. Another thing, a lot of my Indian friends, they were there they were working with the clients, and they were manually finding out this client in audit. This client is filling this month's audit, this month's text, this month's which one is missing? There were a lot of documents. We were just putting it into generative AI, and we were getting the answers. this is the anomaly. This is the thing.
This is the new normal.
One by one, we were but I'm not part of PwC. City is, doing even more tremendous job. So I'm working with the City India. They are, I don't know why you guys are giving us hard time. They are coming up with very good use cases. Very, very good things they are doing, I'm telling you. With minimal resources, they don't have H100s, they don't have very sophisticated high-end GPU compute, but still, their thought process, how they are keep asking questions, keep exploring things, keep coming up with the things. I'm very closely working with them everywhere, not only in India. Indians are not only in India. A lot of countries, they need to mention that, no, we are Ireland, we are not India. There are a lot of Indians, but still we can find 2 or 3 Irish people as well.
Very nice, very nice. So I really get a feel of the work which you are doing, and I can understand now the positions of analysts in your company is going to dwindle significantly. That's quite obvious. Thank you. I'll stop here. Don't need to answer this. Thank you.
Absolutely. Any other question, if Shanti permits?
I have not a question. I just want to have some real life use cases of agentic AI, because most of the time I see some toy examples like even how many batsmen are there. Those are more of academic exercises. So real life where agentic AI being used, I understand the concept. You have multiple agents, they can break it down and do all that stuff. But something which from your experience, if you know of, okay, these are the areas where agentic AI is making a difference. Single agent wouldn't have done the work, and alternatives are really too difficult. So some realistic examples, real issues where you have seen that agentic AI is being used.
Okay, sure. Actually, in academia, people, they are dreaming for the actual complex and applied problem, and we are dreaming for the toy examples. Because we are currently we have 1,500 use cases which we have to implement in our bucket, and all these are, trust me, real use cases and very complex use. We are the use case I was talking about. I would like to again share my screen. The use case I was talking about, we have literally implemented that use case, and through this use case, what we are achieving. This is this use case I'm talking about. Literally, business people, they are sending their queries in English and they are getting the data back. It is very, very useful in the organization. In descriptive, predictive, and prescriptive cases, descriptive is the simplest one, and 80% of the organization is using it. People who were dependent on the developers, on the analyst, on the data scientists, they don't need them. On the database guys, they were sending their query, oh, we need the data to analyze this one to this. They have direct interface through Gen AI to their databases, to their entire data. Either it's structured data, unstructured data, or anything. We convert their query and resolve the problem. If it is a structured data, we convert it into text to SQL. If it is unstructured data, we are using RAG. And in agentic environment, we have combined all of these things. And then we are using protocols A2A MCP. My point here is, these are another use case which, tomorrow, day after tomorrow, I'll be implementing is counterparty credit risk use case. In credit risk use case, there are market risk. We are extracting external data, and then we are processing. We are doing a lot of analysis. External data means a lot of noisy data from the web. We are pre-processing it. We are converting it into structured insights. We are extracting sentiments. We are extracting topic clusters. We are extracting a lot of things. So all of these things within an agentic AI environment, we are using it. Then in credit risk, forecasting and extrapolation is another thing. Predictive analytics is another thing. These are our core components which we are combining to solve the bigger problems. These are our libraries which are providing us these things. So all the this use case we are using this use case on that. This use case is basically implemented. I'm sorry, I'm using the wrong slides. Sorry, just give me a second. Okay, hopefully be able to see it. Yeah. Okay, for the conference. Okay, so this use case, which I was showing you, exactly that approach, this approach, we have applied here. We have applied here. So, sorry, I missed your name.
I'm Sukant.
Sukant, just imagine one thing. Previously, there was machine learning. It was solving one task at a time. We were preparing the data. We were doing engineering, feature engineering, and everything. It was very accurate. Now generative AI is there. We are blindly pushing the data. We are not preparing it, regardless of its quality, the quality of the PDFs, other things. Images are there. PDFs are processed as images. So how we were giving in the initial period rubbish noise to the model. This basically agentic vision technology, agentic data extraction is the name of ADE is the name of the project. This project we are using, this model we are using to extract this one in accuracy. You know how much boost we are getting? Up to 30 to 35%. Earlier we were getting wrong tables. We were getting wrong insights. So tables were misaligned, and tables are key in financial or investment bank. So these are, some of the things, because we don't have enough time. Otherwise, I would love to share a lot of use cases, because I'm into a lot of different use cases, which are applied, which are practical use cases.
Okay, thank you. Just another follow-up to that. Like, can agents create other agents, or the architecture is fixed in the sense like, okay, you have got 3 agents there, and the top agent calling either a tool or a LLM to do the plan breakup and giving to other agents. So is there a dynamic agent creation possible?
Dynamic agent creation is there, but again, I will mention it again and again. Previously, I was with the government, then audit, then financial services. So I am trained on something like a lot of restrictions. So our model risk management is not allowing us to dynamically creating more and more agents and these things. We need to develop applications which are more safe. Otherwise, literally, these applications are productionized, and our banking teams, they are using it. If there is something wrong anywhere, any blunder can cost us a lot of millions of dollars. So that's the only thing. We are introducing some kind of autonomy in the process. But there is some restrictions, some humans, some way, in every use case, in different way we are introducing it. Just like I gave you example of Devon, where we are generating the code, generating the plan, everything, and displaying it to the user. Are you happy with this plan? If user is saying, no, this is wrong, this is right, this is wrong, and then it execute the plan. That's how in every use case we are involving human without minimizing its efficiency, its autonomy, or other things, without compromising these things.
Okay, thank you.
I hope Shanti will not invite me from next time because of the time mismanagement. And
actually, every time we invite you from audience, we have the feedback that please invite him again and again.
And I try my best not to perform good. But if any other question, Shanti?
I think from offline there is no question. Maybe
otherwise you can send me email. You have my email address, and I will spend some time to answer those questions with some evidence. And also I will share my paper around this one. You can share it with the audience, maybe.
Yeah, sure. And I think maybe Sanskriti, you can check if any.
Slides available.
Yeah, Abbas, how about the slides?
I will try my best. It is in the black box, and it's in my office laptop. So how I have to send it to you? I will try my best. Otherwise, you are recording the session.
Yeah,
right?
we are recording the sessions. Yeah, no problem.
So I will try to get the slides. Okay, out of my black box.
Okay, so maybe Sanskriti, you can check if is there any question from online. Otherwise, you can. Thanks to Abbas. So over to you, Sanskriti. But from my
actually
side,
there are-
yeah, from
Sorry?
my side, thanks a lot, Abbas. I think actually I like the session because it's a real practical implementation, how it is implemented in corporate, because many things are like theoretical things and people may not know exactly how it happened in a production environment, and always these things is coming from you. So thanks from my side and from here, from all the participants here.
Pleasure. Thank you.
Yeah, I can provide it. I can provide it. It's with me. I can provide it. Yeah, over to you, Sanskriti.
Sir, actually from online, we don't have any questions. However, if anybody has any questions, they can put it up on the chat box, or maybe I can relay it to Dr. Abbas and then he will answer it.
Yeah.
Sure.
If not, we can proceed with thanking him.
Okay, awesome. Thank you very much, guys, for patiently bearing me, and for more than 1 hour bearing me for these things and everything. Thank you very much. Bye.
Yeah, thank you. Yeah. So I think our next session will be hackathon presentation.